Welcome back. Now this is lecture 1, an introduction to statistical models and Stata. Again, as discussed in the intro, we want to reduce the level of theory. We want to make it very practical, very hands-on. So I will just give you some ideas where things are coming from without going into any technical aspects. Honestly, at the moment it is quite confusing in terms of terminology. Yeah, so we talk a lot about data science when there is data analytics, there is data analysis, there is statistics, there is econometrics, and so on. Then there's machine learning, AI, and so on and so on. Now all of that is quite confusing and not necessarily very helpful, because most of these different terms mean similar things and they tend to overlap quite a lot. So I think it's not necessarily very helpful to think about it. End of the day, what we do here is basically statistics, and you throw in a bit of linear algebra. This is what we do, and that's all you need to know. Whether you want to call this now data science or data analytics, that's up to you. That's a marketing issue, not so much an issue about substance. So what we do here is we try to get some data. We have to have the data in a certain shape. We try to analyze the data, and we try to interpret what we find. So this is basically the idea. Anything else is, in my opinion, how you package all of it and what you label it. Not that interesting. Now, end of the day, what we try to do here is we try to understand, in most cases, how we can improve the way our business or our organization runs. So things we are mostly interested in is all about forecasting. For instance, can we predict demand for a certain product or service going forward? Because once we know that, we can start planning. So the issue around forecasting is really important, really practical. We don't do any theory here, so nothing about actually testing economic theory and all of it. We focus on forecasting, we focus on evaluation of our business policies, so kind of stuff like, okay, what if I do this, should I do it, how can I influence the decision making of a customer, should I lend money to this business, what's the risk, this kind of hands-on practical kind of work. And that's what we talk about. As I mentioned before, I did this course for HMRC, so they have done lots of work on various issues. There's one example here, you can just check this out online. It's about linking alcohol consumption to prices, and of course it's kind of quite obvious, if you increase the price you would expect that consumption goes down. So that was the debate about minimum pricing of alcohol, in particular relevant in the Scottish context. And actually you can see there is quite a significant relationship. That's just an example. So very often what we do is we have a problem, we get some data, we try to get some insights out of it, and for instance in this particular case we can now tell how much more should I increase the price to reduce consumption by a certain amount. Yeah, and of course then you have to dig into the details. So that's the idea. Now again, theory, we are very careful when it comes to theory here, but it needs a bit of it to some extent. So what I tend to do is not any real theory. So what I do is what I might call a drawing. So actually I simply draw relationships. So the obvious thing we just discussed is, well, if the price of a good and service goes up, usually demand goes down. It's not always true. There are exceptions when you think, for instance, about luxury products. But this is what I do. So I start actually simply drawing possible relationships. You might call this theory, or you might just call this maybe, thinking about the structure, thinking about associations. And this is what I would call it. Yeah. The issue which is really a problem is many people believe that if they do some statistical modeling, and we talk about different models in this course, that this model will give you what you might call a causal relationship. So this is the idea that you have a cause and you have a consequence. Yeah. So if I, for instance, let this pen drop, then it falls down. Yeah. So because I let it drop, it fell. So this kind of cause-consequence kind of argument. Now, to be really honest, when we work with actual data, we cannot really be sure that there is a causal relationship. We cannot be sure. There is a whole debate about this, about causal relationships. Honestly, from a business perspective, it doesn't really matter that much, if you're really honest, because most of the stuff we do right now in data science about machine learning, AI, I don't really care. End of the day, what I care about is, does it work? I don't really need to know how it works. I don't care. If I find a relationship and it holds, and I know if A happens, B is likely to happen, that's good enough. I can start making some predictions. I can use it for my planning. So I think don't be too focused on it. It's a big debate, but it's more an academic debate. From a business perspective, it doesn't matter that much. However, what matters is whether these relationships remain stable over time. Yeah, that is important, and we will talk about this later in the course. Now, when it comes to data, the fundamental thing we have to always think about is structure. Structure is absolutely essential. I will do some more stuff on data structures, but this can get very quickly quite complicated. So for this beginner's course, what I have done is I selected data sets that are already very structured. They're easy to use. You just take them, you put it straight into Stata, you do a little bit of editing, and you're fine. In practice, this is not the case. In practice, I spend a huge amount of work shifting about with the data, making sure it's in the right shape, making sure it can be understood by a machine. And this whole issue around data wrangling and all of it, this quite often calls for better tools. Again, Stata is a tool. Stata is very good in certain areas. Stata is not the best tool if it comes to working with complicated, unstructured data. Then I really go into Python. So don't worry about this right now. I will give you data and also show you data sources that have a lot of structure where you don't have to spend too much energy on that. In terms of how you get the data, the main part usually is that you have what you call secondary data sources. Yeah, you get data from maybe financial statements, from the stock market, from various databases. Yeah, from the Bank of England, World Bank, and so on. So this is the most standard common data source. Primary data is the other one. So if you collect your own data, for instance, if you do a survey, if you do interviews. Now this of course goes more into qualitative data. It can go into this direction, which again need different type of treatment. So we don't really talk about this now in this beginner's course. I'm happy to talk about it in a more advanced setting. Experimental data, another area which is getting more and more popular, but of course it needs additional setups. So what we focus on in this particular course is pretty much secondary data. So that's our main focus. Once you go into also issues like social media, APIs, so linking your data collection to something that is happening in real time, all of that can be done. And actually what you learn here you can use in this circumstance. However, you will realistically need to do Python to do it properly. Again, I'm happy to cover this in other courses, but not at a beginner's level. So we focus here really on secondary data. We get very structured data, and then we look into different structures in more detail. The most common structure we talk about is what you call cross-sectional data. So you observe data which we call then variables. So for instance, say age, income, and so on. Location of maybe individuals, maybe households, maybe firms. And we do it at one point in time. So you get a dimension which is focused on these different so-called units of observation. Now, that's the most common data set, cross-sectional. In particular, if you work with surveys, that's the standard. You do it once, you get some data, and then you analyze. The other thing is time series, if you have observations over time, and I'll show you an example in a few minutes. Now again, this is very, very common if you go into financial data, economics, and other areas where you have plenty of observations over a certain time period. Panel data is the combination of the two. Yeah, so here you observe individuals maybe or firms over time. Panel data can be very, very exciting, and we have a whole section on panel data, in particular if you want to look into dynamics, if you want to understand what happens if this happens in future. And then you come closer to the causality argument, yeah, in the sense of what you call Granger causality. So if you think what happens in the past, how this might affect the future outcome. Now this is an interesting area, very exciting stuff you can do with it, and most of my actual applied work is on panel data. Then of course sampling matters. It's a matter of fact that in most cases your sample isn't perfect. There are issues with it. There's issues, how good is the sample, how does it really represent your so-called population. You don't quite often know that. I don't cover sampling here in detail because again what we do is we use existing secondary data sources, and usually the sampling already has been done for us. We don't have to worry too much about this, but this really matters if you do primary data collection. But it needs a whole set of different tools, and we of course can't cover everything. So in summary, what we do here is secondary data, that we don't care too much about the sampling. We have a good structure in place, and we have these three different types: the cross-section, the time series, and panel data. That's just an example how it looks like in practice, and how the structure needs to be for Stata or any other package to understand your data structure. Now that's an example where you have different countries here. We have country A, we have country B, and we have different years. So that's panel data. So we have two dimensions. We have the cross-section, the country, we have the time dimension, which is the year, and then we have various variables. Yeah, in this case GDP growth rate, inflation, and so on. And this is the structure we need. So we have to think about this in terms of organizing our data. In most cases, we already will get this structure from our data source. We don't have to do too much work. In practice, quite often you have to do a fair amount of work to get it in the right shape. But if you look at it, basically every column in this structure is what you call a variable. Yeah, so that's the country, which is your country as an identifier, your year, and any other measures you take. An observation would be in this case uniquely identified, knowing the country and knowing the year. So you need two indices to identify your observation. Yeah, and this is what panel data is. Okay, so I don't really go too much into the issue of causality. As I mentioned before, I already used the term Granger causality if you have a time dimension. The idea is really simple, and that's all you need to know, to be really honest. The idea is that the past, so what happened in the past, can affect the present, but the present cannot affect the past. So put differently, if I observe that in a previous period something is going on, the value of maybe income is going up, and I can then observe what happens in the next period, for instance consumption of alcohol is going up as well, then I can argue that well, income increase boosts consumption of alcohol. I can do that because there's a time difference. Certainly what happens in future alcohol consumption increase doesn't affect the past, except you permit time travel, and we know unfortunately it's not working. Well, we can test that. So if any one of you discovers time travel, leave a comment below and we know actually it works. Is it a proof? Not so sure. Anyway, let's continue. Now the next thing is about ceteris paribus. So this is a Latin term. It kind of is not always easy to translate. I did Latin in school. It was a waste of time, except for this particular thing. So did it pay off? No, it didn't, but it's good to know. You can just show off for a few minutes. Now the idea of ceteris paribus means that you make what you call a partial change and you assume all other things are equal. So the idea behind that, and this is the idea of what we do a lot in statistical modeling, is if you change, for instance, income as one of your variables, which you might call the independent variable, and you look at alcohol consumption, which is the one you try to explain, which we call the dependent variable, then you assume that if I change my income, that's the only thing I change. Now, that's an assumption, and these assumptions, they are plausible if we talk about maybe small changes. But to be honest, it's an assumption, and quite often this is not really true. Very often when you start changing one thing, other things also change. So if you, for instance, think about income, and your income indeed goes up, it's quite possible that you have to change jobs. You might need to move. You might need to sell your house or whatever. This might have an impact on consumption. So it's not really the case that you can hold all other things equal, but that is basically the idea behind it. You call this a partial impact. So it's important to understand that. Again, there is a little bit too much theory on this slide, but so this is what we capture when we write down our models. I don't want to dwell on this. I don't want to go into approximations and all of it. I'm more than happy to expand it further. I did lots of mathematics for many years. You can always leave a comment below if you want to know a bit more about approximation and Taylor and whatever. I don't think we need this. So fundamentally, if you look at this equation here, what it basically tells you is a few things. Number one, what you see is you see these subscripts, so the indices I and T. Now the convention is that I would stand for your cross-sectional dimension. So you can imagine households, firms, individual. T stands for time. So this we know, just looking at this, is panel data. The Y here on the left hand side is your dependent variable. This is what you try to understand. This is what you try to model. On the right hand side you have different independent variables. Again, depending on your discipline, you might call them differently. You might call them covariates, for instance, if you're into biostatistics. It doesn't really matter. Yeah, so end of the day, on the left hand side is our dependent variable. This is what we try to explain, say alcohol consumption. Right hand side are our independent variables. This is what we use to explain our dependent variable. Then we have other things popping up here. First of all, you notice we have here a term which we denote as alpha. So we use Greek letters usually, which is the constant term. So what does that mean? The constant term is the value of your dependent variable if you put all other variables on the right hand side of this equation equal to 0. This is quite often not really possible. It's just mathematically needed to make sure you level it out. Yeah, and we come to this in later sessions in much more detail. So the next thing you have to understand is other coefficients. So the constant term is one coefficient. It doesn't change. It's constant. This is why we call it the constant term. Then we have coefficients which are linked to your independent variable. We have here the beta coefficient times the price. And you see price is the same across cross-sectional units. This is why when you look at the subscript, there is only the time dimension. Of course, that's plausible. When you go to the supermarket, you don't get a special price just because it's you. Yeah, you pay the same price. Now, the beta coefficient is called the slope coefficient because that's the slope of the equation. And you will see this in a minute when you look at the visualization of this in a diagram. You see that this is actually the straight line, and the slope of it would be the coefficient which is denoted beta in this case. Now, this slope coefficient beta tells you the sensitivity. It tells you basically what happens if price goes up by a certain amount, what happens to my dependent variable. Now, the gamma coefficient is the same. In this case, it's linked to income. And then you have the error term. Yeah? And the error term is basically capturing all the randomness, because end of the day, what we do here is statistical modeling. So there is always a significant degree of randomness, because obviously the model we write down here is not perfect. It's not. It's an approximation. You know, who knows how this actually might look like? We write down here, in fact, a linear model, but it doesn't have to be linear. You know, who knows? It could be all sorts of things. It's certainly a simplified version of reality, and that's important to understand. What we do in statistical modeling is an approximation. It's good enough in many cases, but it's not perfect. It's certainly not perfect. So the error term permits a deviation from this approximation. We make certain assumptions about this error term, which we talk about later, but basically it should really be random. There should not be any systematic difference between your theory and what you actually observe. So that's at least the idea. Good. Now, when it comes to visualization, I think this is quite helpful. So here you see again these terms popping up. So that's only looking at the price and consumption. You would assume if price goes up, consumption goes down. So you have here a beta coefficient that is negative. Yeah, so you increase price, the value of consumption goes down. If you change your price by one marginal unit, so you make a tiny bit of a price increase, you reduce the consumption by beta units, which is your slope coefficient. And then you see the value of the constant term, or also called the intercept. So if you put the price equal to 0, which is of course only hypothetical, so basically giving away stuff, that should capture the consumption level. Again, this is more hypothetical, yeah, because we actually don't really observe this. We don't quite know what happens if you really go to very low levels of price. So what you do here is you start with the same equation which you saw before. You have your dependent variable, you have your constant term, you have the slope coefficients, you have your independent variables, and you have your error term. Then in a technical sense, and again this is theory, careful, you take a partial derivative. This little ugly symbol here is the partial derivative with respect to price. So what you do here is exactly what we talked about before. I assume I only change the price without changing anything else. In our case, the anything else would be income. I think this is more or less a plausible assumption. Yeah, more or less a plausible assumption. And when you do this in this equation, you just take the derivative with respect to price, well, you end up only with the beta. Anything else doesn't contain price, so it drops. Yeah, so you get here the beta coefficient. So, and that captures the sensitivity, as you can see in this figure. So that's the intuitive explanation of what happens in a box standard linear model. It's linear, yeah, so there's no curviness going on here. Of course, we know it's only an approximation. It's maybe true if you have not too radical changes to it, yeah. So for instance, if you change the price to 1 billion, it won't be linear anymore. If you change the price to 0, it won't be linear anymore. So these kind of models, they work quite well if you don't make radical changes. Yeah, so they work quite well if it's kind of what you call a marginal change, a tiny bit of change, but not too radical. All right, good. So we covered the nitty-gritty of statistical models and how to visualize them. We talked about the different terms we tend to use. Again, if you need to go back to these concepts, you can always do so. You can always stop the recording and actually that's important, and try it yourself. Good, now I move into Stata. So I jump into my Stata. I opened it up here and I just talk you through this a little bit more. So when you open it for the first time, it looks quite intimidating, but actually you will get used to it very, very quickly. So you have your main screen here, so that's for display. You have your command line down there, and this is what we use an awful lot. You have a list of previous commands, which is useful. And if you open a data set, variables should show up exactly here. Then you have so-called do files, which you find up there. That's the do file editor, and you can just click on it and it opens up. Now, what is a do file? A do file is basically like running a script. So what you do is you use the commands and you write them down in this do file, and you can execute that. The benefit of working with do files is you can always replicate your findings, and that is fundamentally important. This is important in business, but also in general. Yeah. So whenever you do any empirical work, it's important that you can give the data to someone else, and this other person runs your do file, and you get the same outcome. This is what you want. You want to make sure you can replicate. So I strongly suggest you work using do files. Absolutely the right thing to do. Yeah, because you capture what you do, and most importantly, you can replicate. Good, let's get started. What I have done here is I downloaded some data. It doesn't really matter what kind of data you want to use. Again, you find the data on GitHub. This is for the first lecture. This is house price data, which I obtained for free using Nationwide. The link to the data source is already in the Excel file, so if you want to get some more data. Nationwide is great because all the data is for free. You can just download the data and you can use it for your own analysis. Many years ago I used actually Halifax, but Halifax was clever enough to now make money out of the data set. So my recommendation is don't spend the money, use Nationwide. It's pretty good as well, and honestly speaking, particular for a student, it doesn't make any sense to spend money on data. So this is what I have done. So we have the data set here, and you can see this is an Excel file, which is fine because actually it's quite useful to use Excel for data input. I just open this up and we talk a bit about structure, and we talk a bit about how we get the data into Stata, and there are different ways of doing it. Good, so what you see here is we have the house price for different types of houses. Honestly, we don't really have to understand the details. I will zoom it a bit now. It's easier for you to see that, and also for me, it's getting worse when it comes to my site. Okay, so we have here quarterly data. You see that quarterly data starting from 53 and going all the way up to 2022, hopefully. No, it stops in 2021. Well, that's fair enough. We are not yet in the first quarter in 2022. We have here the actual price, and then we have price changes, and we have the index. So the index is basically an index which is kind of leveling out the price level. So it's up to us to decide whether you want to work with the index. It might be easier, or with the actual nominal price in pound. Again, I don't want to go into the arguments about the finance behind all of it. It's not really important. Good. So how do we get the data into Stata? Okay, the first thing I would always do is I would simply make sure that the data is in the right format. So if you just mark your data, we just mark a little bit of it, do a right click on it. If it works, it doesn't seem like, here you go. You go to format cell and you get data formats. It doesn't specify anything. I would advise you to put in general. This usually works the best. Yeah, and you see it's a bit changing here, because if you copy paste otherwise, you might get sometimes some errors happening. So what we do is we cover the whole bit. So I do Control Shift, and then I do the arrows here to cover everything. So it's Control Shift and the arrow down or up or anything. Right click format cell, I go to general format. That usually works best. Okay, so try this yourself, try this at home, and have some fun with it. Now in our case we just now want to be selective. Okay, we just need the index, we need here the time dimension, maybe that's all we need. So what you can do is you can just copy paste that straight into Stata. Now in Stata, when we move back, you see up here the data editor. Yeah, there's the data editor, the browser. You can just look at your data, or you can edit. So if you go into the data editor, click on this, this happens, and now you can start editing. You can start typing or copy pasting. We do a simple copy paste here. Yeah, the only thing I want to do is I want to name this. Before I just call this here time, and I call this index. Yeah, I just want to have it all in the same format, and we just copy paste. Again, I use Control Shift and arrow down. Copy paste that straight into Stata. This is the easiest way to do it. I just move up here and I copy, and it gives me now the option whether I want to treat the first row as data or as variable names. In my case, I use variable names. Yeah, and here we are. That's all. So this is the easiest way to do it. There is a more fancy way to do it, but that's the easiest way to do it. Good. Right. What you see is that the index has a color, which in this case it's a black color, which indicates this is numeric, which is great. This is what you want. Time has a red color, which means it's actually loaded here as a string. So that's text. So you have to work with it to get it in the right format. But basically that's all there is. So we have now the data. If we close the data editor and go back to our Stata version, you see now it's popping up here as variable. Yeah, so now we have our data, and if we do a little browse here, it's coming up, and we have our data. So that's pretty cool, isn't it? Good, so that's one way to do it. That's the easy way, and honestly, if you have a small data set, it's good enough. Absolutely good enough. The other thing you can do is you can load data straight from your files. Yeah, but you need to do some work on it to make sure it's all loaded correctly. So again, I just mark what I need, and I open a new one and I copy paste that in. Let's do that. It is quite often actually better to get rid of all the formatting. I usually like this more. So if you do the paste special, you just select values, because this formatting doesn't really help you. It could cause problems, so best not to use it. And so this is just now using the values. I save it as a file. And I move to this right folder. That's important, otherwise, well, I can store it wherever I want actually, but then I have to make sure I link it to the right folder. And I go to my data science stuff, I go to data, I go to lecture 1, and I throw this in here. I just call this for data import. And I use actually a CSV file. This works better. So if you go down there, you save it as a comma delimited file or CSV, and that's it, execute. Yeah, so it's now data_import.csv. Good. Now in Stata, we can have access to the data directly. Let me just clear. Now clear removes, as you can see, all data in memory. So now again we are empty. I move to the do file, and now I start doing some little coding. Let me zoom that a bit to make it easier for you. You see here we have a zoom in, maybe a little bit more. So that might be better. I just call this here data input. So if you want to make a comment, you just put an asterisk in front. It's always good to comment what you do. I would save that now also as a do file. I save it. I save it under lecture 1, and I just call this whatever you want to call this, maybe data also import, but it would be then a do file. Yeah, it's fine. Good. The first thing you need to do is you have to navigate to the place where you have the data, and that's basically you need to change your directory. Okay. So change directory. You have to go into your current directory where you want to work, your working directory. So we already are here. So if you are on a Windows machine, the easiest thing to do is you simply click up there and you get the path. Yeah, you see that? You just copy paste that, and you will see in a second where we run into a problem. You copy paste that, and you put quotation marks around, so you treat this as a string, and you do a cd change directory, and we can try this. And just save that, and let me just, it's all clear now, that's fine. I will also close this, we don't need it anymore, and we try to execute that. Let me see. Okay, so we should be now, fingers crossed, in the right directory. Sometimes older versions of Stata can be a bit funny about spaces, so you have to be a bit careful. Sometimes it doesn't like the space. So yeah, so that's something to have in mind. So now what we do is we go here and import this using a command. So I just copy paste the name, go back into my do file, and I now do the insheet command. Exciting, your first command, insheet using, and then I use the name of the file and execute that. The thing is, I do a lot of coding in Python, so I will make syntax mistakes because I'm very much used to Python, and these two are so different, and so you have to bear with me. Okay, so I did the insheet using the name of a file, and now you see it popped up here. Let's do a little check. Here we are. It's all loaded. So now we are ready to go. Isn't it exciting? So that's great. So we did cover the basics. We now played around with Stata. We explored the do files. We got some initial data into Stata. So now actually we are ready to explore our data. Isn't that exciting? I see you in the next one.